Namaste students. Reverend Dr. Jason Mathan from Department of Food and Biotechnology, Faculty of Agriculture and Veterinary Science, Jyoti Vidyapeeth from Jaipur. Today I am going to discuss about the topic assimilation of sulfur. So, what is sulfur? First, sulfur assimilation. We have so conversion of inorganic sulfur compounds such as SO4 into sulfur containing organic compounds such as cysteine plants is called as the sulfur or sulfate assimilation. Means plants are synthesizing some amino acids which contain sulfur. So these are the organic sulfur compounds are produced from sulfur. So this is known as the sulfur assimilation. The first step in sulfate assimilation in plants is the conversion of sulfate into cysteine. So sulfur in sulfate is present in highly oxidized state with 6 positively charged, while in cysteine it is present in reduced state with 4 negative charges. Therefore, conversion of sulfate into cysteine is a reduction process that is energy dependent and it requires ATP. It entails transfer of 10 electrons which are provided by reduced glutathione GSH, reduced ferrodoxin and O-acetylserine. So the enzymes which are involved in the components which are involved in this is the 10 electrons. These are reduced glutathione, reduced ferrodoxin and O-acetylserine. Adenosine 5-phosphate, sulfide are important intermediate in sulfur assimilation. So we need to note down all these things. So what are the components and what are different intermediate? APS, adenosine, phosphosulfate, sulfide. Okay. Okay. So now talk about the various steps in the process of sulfur assimilation. So first step is that what is the first step? In the first step, the sulfate is activated by ATP in the presence of enzyme ATP sulfurylase. So first enzyme is the ATP sulfurylase. Okay. So the enzyme ATP sulfurylase. Okay. This enzyme will activate the sulfate and form APS. It will form adenosine 5-phosphate phosphosulfate and pyrophosphate. Okay, so the reaction will get SO42 plus Mg ATP, and this will convert adenosine 5-phosphosulfate plus pyrophosphate. In this reaction, Mg plus 2 ions are required. Pyrophosphate is formed is quickly hydrolyzed by the enzyme inorganic pyrophosphate. Pyrophosphate is between 2 molecules of inorganic phosphate. Okay. So the PPI which are produced will be hydrolyzed and they will form 2 molecules of the now the second step, the APS, which was from the first step, the product of the first step, the APS is now reduced. Okay. The enzyme APS reductase transfers 2 electrons from 2 molecules of reduced glutathione to produce sulfide. Okay. Glutathione is oxidized in this reaction. So the APS plus 2 glutathione, 2 GSH molecule will produce SO3 minus, or it will produce sulfide. Okay, and two protons will be released, and this GSH is now oxidized into the GSSG. Now talk about the third step, sulfide. So in the second step, the product what? SO3 minus 2. So in the third step, the SO3 is now reactant. The SO3 is now reduced to form sulfide in the presence of enzyme sulfide reductase, and this reaction requires 6 electrons. This reaction requires 6 electrons, which are provided by the 6 moles of the reduced ferredoxine. SO3 plus 6 electrons from the ferredoxine will come in contact with each other. They will react and they will form sulfide S2 minus. Thus, 6 electrons will be released. Now go to the final and last step. The sulfide will react with the O-acetylserine OAS. Okay, the sulfide, which was the product of the third step, it will react with the O-acetylserine under the influence of the enzyme OAS thiolase, and it will form the amino acid cysteine and acetic acid. There is a transfer of 2 electrons in this reaction from OAS to sulfide. So OAS plus S2 minus will form cysteine plus acetate. And the OAS is formed from the serine and acetyl bonding in the presence of enzyme acetyl serine acetyl transferase. The sulfate assimilation takes place chiefly in chloroplast. The sulfate absorbed by the roots from soil solution is translocated through xylem to source for assimilation. Okay. Now we can also talk about the formation of some the sulfur containing organic compound after synthesis of the cysteine, and of the sulfur containing amino acid like methionine is synthesized from it. This newly synthesized cysteine will synthesize new sulfur containing amino acid like methionine. Okay. Therefore, other sulfur containing organ molecules are synthesized from two amino acids. So first we talk about the synthesis of methionine from cysteine. So various steps are involved in the synthesis of methionine from cysteine. Okay, in the first step, cysteine will react with the O-phosphomonoserine in the presence of the enzyme cystothionine alpha synthase to form cystothionine. Okay, inorganic phosphate is released in this reaction, and in the next step, the enzyme cystothionine beta lyase splits cystothionine into the homocysteine NH3 and pyruvate. Next, finally, the last step, the homocysteine is methylated by the enzyme methionine synthase to form methionine. So, finally, methionine has been synthesized. Synthesis of methionine from cysteine also occurs in chloroplast in leaves, and the sulfur-containing organic compounds produced after sulfur assimilation are exported to other plants, other parts of the plants, such as the roots, through, and they are also transported to the fruits through phloem, glutathione. And it is believed that the glutathione may also coordinate the absorption of sulfate by roots and its assimilation by the shoots. So this is all about the assimilation of sulfur and sulfur containing compounds. So my lecture is over here. What kind of questions which can be asked from this lecture? The question which can arise from this lecture is that explain the assimilation of nitrogen and what are the basic features of what are the basic features of the sulfur assimilation? Give any examples of sulfur assimilation, like say from sustain how the methanol can be synthesized. So everything is explained in this lecture. So my lecture is over here. If you have any query, you can ask me. So thank you very much.